Hi Daniel, thank you for coming to our 2025 Cell and Gene Therapy Conference at Philly. This conference has been here for like 4 years, and is this your first time too?
It is my first time, yeah.
How's your experience so far?
It's been excellent so far. I mean, we have a nice cross-section of folks from industry and academia and a large number of participants and also some of the world leaders in the field. Mm-hmm. We're lucky geographically that many of them are here, and that I think really elevates the conversation. So it's off to a great start.
Yeah, thank you for coming, and we are honored to have you as our speaker, and a very nice talk. And could you briefly describe yourself, introduce yourself a little bit to the audience here? Mm-hmm. Like what's your background, and what's your vision for the cell gene therapy? Yeah.
Yeah, so my background is in bioengineering and actually epigenetic regulation of gene expression, and really my vision for gene therapy is that sequence design can lead to, or better sequence design can lead to better medicines, mm-hmm. right? In nucleic acid-based medicines, really it's the sequence that drives function, and we need to engineer at every little piece of the vectors that we're developing the best possible sequences. So the field has made it quite a lot of advances by using well-studied sequences to show the potential promise of gene therapy, but now it's time to push the envelope and go beyond sort of the standard workhorse promoters or non-optimized transgenes and really improve on those sequences to address kind of the next set of diseases or disease indications. Yeah.
Thank you, that's nice. Yeah, I have been hearing a lot of discussions about platforming, right? So from the early discovery, we want to make the nice, optimized promoters, optimized capsid, everything optimized, and so that we can utilize this platform to move forward and utilize it for the clinical studies as well. So because you are in this more like discovery world, what's your opinion or suggestions for this early discovery to connecting with the later like CMC development to make it more streamlined or conversation more smoothly for this type of platform technology development?
Yeah, so I think the key idea is that you can't just have one metric of success. So because you're delivering a medicine that needs to package in a capsid, the way that the DNA sequence folds up into a genome, how it interacts with the capsid, how it forms an episome, then how it recruits transcriptional machinery to make a transgene or make a therapeutic RNA or mRNA. Every one of those steps matters, mm-hmm. and if you have an assay where you're saying the optimum thing is gave me the highest value of X mm-hmm. in this one assay, but you don't consider all the other steps that the DNA needs to carry out to get a final drug that works, you really may design a sequence that has some flaws in it or other challenges that were unexpected because of being hyper-focused on one readout. So the interactions with CMC very early on help us anticipate those problems and make sure that we steer clear of design space that our CMC colleagues know are going to be problematic, or basically build a gene therapy that works very well in cells or in mice, but can never work in humans because we can't manufacture it, right?
Right.
So addressing those at the outset is really, really critical, because even if you think, well, we have brilliant colleagues in manufacturing and they will figure out a way to solve it, they oftentimes just don't have enough time. Mm-hmm. Once things get to IND readiness, there's a very short time frame for scaling them up to a clinical scale of vector production, and so even if they're smart enough to solve the problem, they don't have the time. So you've got to build that in from the beginning.
Yeah, that's really good point,
yeah.
And really appreciate your come here, and hope you're enjoying the rest of the conference.
I look forward to it.
Yeah.
Yeah, thank you for the